Imagine a massive, stadium-sized rock hurtling toward Earth at record speed, arriving in absolute silence with zero warnings. You would expect sirens to be blaring, but our detection systems see nothing. This object is perfectly camouflaged within the blinding glare of our own sun. Think of trying to spot a tiny firefly buzzing right next to a massive stadium floodlight. The extreme brightness completely overwhelms your vision. That same optical overload happens to our telescopes. When a massive space rock approaches from the inner solar system, its faint reflected light is completely drowned out by the overwhelming solar glare. Our most dangerous cosmic neighbors are shielded by the very light that sustains life on Earth. We experienced this exact blind spot in 2013 with the Chelyabinsk meteor in Russia. Because it approached entirely from the direction of the rising sun, absolutely nobody on Earth tracked its approach. The first warning anyone had was when it suddenly detonated high above the city. That single rock shattered glass across the entire region and sent over 1,000 people to the hospital. That meteor was only 18 meters wide. A rock the size of a skyscraper dropping out of that same solar glare would level a major metropolitan area. Because scientists know these massive rocks are out there, they use a specific optical workaround to hunt for them. The brief twilight hours just before dawn and immediately after dusk. This 3D diagram shows exactly how that works. By waiting for the Earth's curvature to act as a physical shield against the direct solar rays, astronomers secure a narrow low-light wedge. During that fleeting twilight window, sensitive instruments like the dark energy camera rapidly scan the horizon, looking for faint reflections before the sun fully rises or sets. By using the planet's own mass to block the solar glare, researchers have established a reliable way to scan the inner solar system. Staring through that twilight window, astronomers spotted two massive bodies, an 800-meter asteroid named 2022 AP7 and a 700-meter rock, 2025 SC79, affectionately nicknamed Scooby. This orbital map reveals Scooby's extreme path. It belongs to a rare class called Asteroids, carrying an incredibly fast 128-day orbit locked entirely inside the orbit of Venus. Living deep in the inner solar system means Scooby constantly bakes at temperatures exceeding 220 degrees Celsius. Most standard space rocks would crumble under that kind of intense thermal stress. Scientists hypothesize they survive by being composed of incredibly dense metal. The inner solar system produces dense, high-velocity masses, tempered by the sun's extreme radiation and gravity. A direct hit from a 700-meter mass like Scooby would shatter windows 16 kilometers away, trigger 7.4 magnitude earthquakes that ripple outward for 500 kilometers, and kick enough debris into the atmosphere to alter the global climate. You don't need to panic. Tracking data confirms neither Scooby nor 2022 AP7 are currently on a collision course with Earth. We rely on automated monitoring networks like NASA's Sentry system, constantly cataloging over 40,000 near-Earth asteroids and mapping their precise trajectories centuries into the future. Continuous observation and rigorous mathematical modeling turn what used to be a terrifying unknown into a highly managed, low-probability risk. NASA's historic DART mission proved that we can physically smash a spacecraft right into an asteroid to successfully shift its orbit. We are also moving beyond ground-based twilight scanning by launching new observatories completely free of the Earth's atmosphere. The upcoming NEO Surveyor telescope is designed specifically to stare straight into that solar blind spot from the vacuum of space, catching these objects long before they approach us. Humanity is actively engineering the tools to eliminate our final cosmic blind spot. If you want to stay sharp on whatever the universe throws at us next, hit subscribe. Drop a comment telling us what you would do if you discovered a brand new asteroid, and we'll see you next time.